The next thing we're going to attempt to do is to verify some identities using all these double angle identities and product to sum and sum to product identities that we've just established. To do that, I notice, this one here in particular, this is a kind of a tricky one. I haven't really looked at this one very closely yet, so I'm making it up as I go. Again, it is establishing an identity, so we could start on one side and try to derive the other, or we could start on the other side and try to derive the first, or we could work on both sides and try to get a common expression. Any of those approaches will work. As I'm looking at this though, I see a lot of 2a's and a's as the angles, and you really can't do much with trig functions until all the angles are the same. So let's change all the 2a's to a's using our double angle identities. I know that the sine of 2a is equal to 2 sine a cos a. It's the only equation that it's the only identity for the sine. There are 3 identities for the cosine of 2a. I'm going to start with the sine because it limits my options, and then see if that narrows down in any way what I want to do with the cosine. So let's go ahead and maybe I'm going to do this one by working on both sides and see if we get to a common expression. So let's take the middle one here. In fact, I'm going to separate this off, separate the board so I don't get confused. I'm going to work on the left side separately, work on the right side separately, and see if we can't get these down to the same thing. First of all, sine of 2a is 2 sine a cos a. And then I'm not sure yet what I'm going to do with this, so I'm going to hold off on that. On the other side of the identity, or potential identity I should say, is sine of 2a, which does simplify to 2 sine a cos a. And then I still have my other stuff, minus 4 sine cubed a cos a. As I'm looking at this, just kind of looking at patterns, there's not a whole lot interesting. Let's see. I've got to multiply by something here. So I guess the question is, do I want to change this to the cosine squared minus the sine squared? Or do I want to change it into 2 cosine squared minus 1? Or 1 minus 2 sine squared? So I've got some options, right? There are 3 options for this. And as I'm looking at this, I notice that actually, before I go further, this is going to be a product of 2 things, right? The cosine of 2a becomes something here. What if I were to rewrite this as a product? Maybe that would help relate the 2 sides, potentially. To do that, I notice here's a 2 sine a cos a. What if I were to pull a 2 sine a cos a out of these 2 terms? It's a common factor, right? There's a 2, there's a sine a, and there's a cos a. If I pull that out, it might help to narrow down our options. So let's do that. Let's pull out a 2, a sine a, and a cos a. And if I pull that out of this first term, well, that's everything, right? So that leaves us with a 1. And out of this, I have a minus, and then pull out a 2 from a 4, I get a 2. Pull out a sine from a sine cubed, and I get a sine squared. And then if I pull out a cos a, I don't really need to, well, I don't have anything left, right? The cos is gone. All right. So on that first line, I should probably write out what I did here. This was a double angle identity. And here, this is just factoring. Factor out GCF, greatest common factor, okay? Oh, jeepers. Well, look at this. 1 minus 2 sine squared is one of our formulas for the cosine of 2a. I really didn't even need to look at the left side. Check that out. So this actually works out nicely because this is our double angle formula for the cosine of 2a. So let's do this. In this set of parentheses here, or maybe I'll even ignore the parentheses, I can multiply. I'm going to turn this into, yeah, I do need parentheses, don't I? I'm going to turn the cosine of 2a into 1 minus 2 sine squared of a. That's also using a double angle identity. Okay. And now what I've done is I've shown that using a double angle identity in a couple different places, I have this expression on the left, 2 sine and cos A times this difference. And on the right, I also have 2 sine and cos A times that difference. And so I've basically shown that both sides can simplify to a common expression, which makes them equal. Okay. Yeah, so these two expressions here are the same. And that establishes the identity.